Okay, let's see if I can get this video going for you. Hopefully yesterday worked out okay. Remember, if you don't have internet access, you can always read in the book. But the links are there and you should be able to find both videos or break if you need to. Okay, so this next one, we're still solving for systems of equations. We're just doing it in a different method. So remember back yesterday when you learned what solving a system meant? Solving a system means where two lines cross, and it's the point that they cross at. So it's the ordered pair. That's the answer to the system. A system means more than one line. We're only dealing with two lines right now. Although I think in homework, maybe there's a challenge problem on homework. Hold on. Okay, so sorry about that. So a system is where the two lines cross. So we're not going to be graphing them today. We're going to do it algebraically. And there's a couple different ways algebraically that you can do this. And one of them is substitution, and that's the method that you're using today or you're learning. So you can see this is what we learned yesterday. If you want to pause it and draw this, that's fine. If you don't want to draw the graph, you don't have to. I'm going to use it to explain what it means to use substitution and why it works, but you don't have to draw the graph part. Okay, so I didn't write a target because a target is the same as a title. You're learning how to solve them through substitution method. So you can see from this drawing that the red equation, which is y equals 2x, I graphed that. Okay, you can see that I graphed the red one by knowing that the slope or the intercept was 0 and the slope was 2, which means it crosses at the origin and goes up 2 over 2, up 2 over 2. The program is hard to draw the arrows on there, so just pretend there's arrows on those lines. The purple one, I crossed at 5. 2, 3, 4, 5, yeah, just making sure, and the slope is up 1 over 1. So you can see from all that they intersect right there, which is going to be at 5, 10. Okay, where 5 is the x. I murdered that. X and 10 is the y. So this 5, 10 is a unique point because it's the only point the two lines will cross out. It's the only set of ordered pairs that work for both equations. If I use any other set of ordered pair, if I pick out a point off of the red line, if I pick that point, that's 1, 2. And if I try to use 1, 2 inside this equation, I will get 2 equals 2 times 1. Pause this and talk about this if there's somebody in the class that doesn't understand where I'm getting those numbers or what I'm doing. But I can see that the point 1, 2 is true for the red equation. So I can turn around and try this in the black equation, or the purple equation. And it would be 2 equals 1 plus 5, and I get 2 equals 6. So you can see that the point 1, 2 would not work for the purple equation, which makes sense because the point 1, 2 is not on the purple line. So the only point that works for both equations is the solution. So knowing that they share an x and a y, erase this part, you can use that algebraically and set up an equation. So I know that the y works for both equations, okay? So I know that if I say that y equals 5x, 5x is the same as this y. So I can substitute that in for that y. So I can take the x plus 5 that's in purple. Actually, let me do it this way to try to make sense of it for you. I can take the red equation, y equals 2x, and I can take out the y and I can replace it with x plus 5 because the purple equation says that y is equal to x plus 5, so that means they must be the same thing. So now I can take this equation. What's nice about this equation is that I only have one variable now. You don't know how to solve an equation with two variables in it, but you do know how to solve an equation with one variable in it. So now I can go ahead and solve this equation, and I can pull all my x's over to one side of the equation, and I can get x equals 5, which that's what was up here. I knew x was 5, but I wouldn't have known that if I hadn't graphed it. So once you get the x, how could you get the y? You could plug it back in to one of those equations and get the y. Does it matter which equation you plug it into? Absolutely not, because they share the same x and y. So I look for the easiest equation. I'm going to go ahead and plug it in. I mean, they're both easy here, but I'll go ahead and plug it into the red equation. So sorry about that, the purple equation. So that's y equals x plus 5. So instead of x, I'm going to replace it with a 5. And I get y equals 10. And now I know the point is 5, 10. Okay, I didn't have to take the purple equation and plug it into the red. I could have done it the other way. So let me do it the other way. This method is really confusing. You want to just kind of watch for a little bit, and then the first one that you struggle through is kind of a struggle, but after you've done 2 or 3, it all kicks in. So just keep trying at it. So let me reverse this whole thing and start over. That's what's nice about substitution, is that there's multiple ways you can substitute. You get to pick whichever variable you want to substitute. So I'm going to go ahead and erase this, because you wouldn't have this in a problem. They wouldn't tell you that. And you wouldn't have this. All you would have is those 2 equations. So, let me see if I can erase this without ruining everything. Okay, so I know that y equals 2x in the red, right? So I'm going to turn around. Maybe I want to use the purple equation. Purple equation said y equals x plus 5. Oops. So I can take what I know to be y in the red equation and substitute it in for the purple equation. I'm not substituting it in where the x is, because y equals 2x, so I'm substituting where the y is. So I'm going to take that y out. I'm going to substitute 2x in so that all I'm dealing with is one variable. Now I'm going to solve, and I get x equals 5. And then I'm going to take that 5 and I'm going to substitute it back into either equation. So maybe I'll do it to the top one now. And get a y. Y equals 10. That's a 5. Okay, so maybe when we do the next one, you walk through it on your notes with me. Let me set it up. Okay, so here's the 2 equations. So the directions are telling you it is a system, and you're trying to find where they cross. So if they cross at the same point, they share the same x and y no matter which equation you use, the x and y are going to be the same. So you're going to substitute one for the other. Okay, so I'm going to go ahead and I'm going to take, maybe I'll take this one and I'll substitute it into here. So I'm going to rewrite the whole thing. I'll try to stay color-coded for you to help you understand. So you've got the 2x plus 5, that's the y off of the purple equation, and you're substituting it into the red equation for the y. So now I'm going to solve for x. Now I know that the answer has a -2 in it for the x, and I'm still trying to look for the y. So now I've got to substitute this -2 into either equation. So I'm going to go ahead and substitute it into the top equation. And I get y equals 1. So now, voila, I have the answer. So let's write some steps to it. Okay, and there are steps in your textbook. Let me back up on your textbook. There are steps on the first page to 5.2. On page 336, there's steps 1 through 5. And I think that's probably going to be easier for you to copy than for me to try to write them with my finger on this. Okay, so you can pause the video and maybe maybe Mr. Pryor can put a textbook underneath the document camera on page 336 and you can copy down those steps. And then I will do the next problem on here. If you run out of time because it's a short schedule, make sure you either watch the rest of the video at home or go read, because not all the equations are solved for y or in slope-intercept. And the difference is you can just solve them for slope-intercept, or you can work them that way. And the next one I'll try to do that way. Okay, so here's a new equation. So you can see that the top equation is in standard form. It doesn't matter which form they're in. If you don't like it, you're welcome to solve for y and keep doing it the same way that we were doing it. But you don't have to. What you can do is, once one of them is solved for a variable, like you can see that the purple one is solved for a variable, the red one is not solved for a variable yet. Solving for a variable means that the variable is isolated, it's by itself. So whichever equation is solved for whatever variable, it doesn't have to be y, take that and substitute it into the other equation. So I'm going to write 2x plus, but instead of y, I'm going to put x minus 4 and equals 5. And I'm going to solve. So that's going to give me 3x minus 4 equals 5. I'm going to pull the 4 over. I'm going to get 3x equals 9 and x equals 3. So now I know that x is 3, so I can start writing my answer. Your answer is the ordered pair. And yes, you have to have all these steps. Okay, so now I can plug the 3 into either equation. This is where it's kind of nice, because if I plug the 3 into the red equation, I'm going to have to do a lot more work, because I'm going to have to then solve for y. The other equation already has it solved for y, so it's easier if I take the purple equation and instead of x I put a 3 and I solve. And there's my answer. If it's truly an answer, if I did it right, how could I check it? You can check it like you did yesterday. That should be the only pair that works for both equations. So mentally you could run it through and see if you plug in 3 for x and negative 1 for y, would it make the red one true? Then do it again for the purple, would it make the purple one true? Okay, so you try this one and then you can pause the video. So I'll give you x plus 4y equals 6, and I'm just taking these right, oops, 6, just taking these right out of the book. And x plus y equals 3. So now neither one of these are solved for a variable. So the first thing you're going to have to do is solve one of them. You can solve both of them for y if you want to and do it like the first example that we did, but it's a lot of work. Remember, you can solve for either variable. And so maybe on this one we should solve for x. Okay, but there's no reason we couldn't solve for y. Which is going to be easier to solve for x, the purple or the red? And it doesn't matter. I'm going to go with the red. So I'm going to rewrite the red one as y equals negative x plus 3. I skipped some steps there, but you know, you're halfway through algebra class, you should be able to figure that out, that I moved the x over. Okay, so now I'm going to take, sorry, my dog is chewing a bone. I'm going to take what is equal to y, and I'm going to substitute it in for that y. So I'm going to have x plus 4, and then since y equals a binomial, then I'm going to need some parentheses, because I want the 4 to be multiplied times the negative x plus 3, not just the negative x. So be careful, and you know all this from like chapter 2. Distributive property first. So I get x, minus, because it's 4 times negative x, plus 12. I got the 12 because 4 times 3. I'm going to simplify, so I'm going to get negative 3x plus 12 equals 6. I'm going to move my 12 over. I'm going to get negative 3x equals negative 6, and x equals positive 2. So there's part of my answer, so I know that x is 2. So now I want to get the y. It doesn't matter which equation you use. I'm going to use the red one. So 2 plus y equals 3. So that means if I move the 2 over, y must equal 1. And voila! There's the answer. you don't always have to solve for y. And that one we solved for x. Or no, that one we solved for y. We could have solved for x. So maybe on the next one I'll solve for x. Okay, so here's two new equations. You just want to look at it. You want to say, what's the easiest variable to solve for? Don't take the hard road. When I look at that, I can see that it's going to be the easiest to solve for x with the purple equation. Because if I solve for y, I'm going to have to do some division to get rid of the -4. And if I solve for x or y in the red equation, I'm going to have to do some division on both of them. And I'm going to end up with fractions. And it's doable. You can do it, but it's messy. So I'm going to rewrite the purple equation as x equals 4y plus 11. So you might want to write steps to yourself, you know, say, or write a little note that says solve for whatever variable looks easy. Okay, so now the only thing you got to be careful of is that whatever variable you solve for, you're substituting that into the variable in the other one. Keep the variables the same. So right now I substituted x, or I solved for x. So I need to make sure that I substitute into x, not into y. So I'm going to rewrite it down here. I have 4y minus 5. I need the parentheses because it's the quantity, it's the binomial. 4y plus 11 equals 9. I'm going to have to use some distributive property. When I distribute, I'm going to have to make sure that I pay attention that that's -5. So I'm going to get -20y minus 55 equals 9. And then I'm going to get -16y minus 55, and you should be good on this because you have passed the first half of algebra, hopefully. And 55, 65, 64. And divide by -16. I'm getting sloppy, sorry. Y equals -4. So I know that my ordered pair is -4. I want to make sure I put that in the y, not the x. So sometimes if you're not paying attention, then you kind of get in the habit of always putting it first. I know that y is -4, so now I can plug -4 into whatever equation I want. I'm going to go ahead and do it into the purple. But remember, you can do it into either equation. I would plug it into your original equations, not the one that you changed, just in case something went wrong. This way you'll know if you... I guess you wouldn't know if you screwed up, but it's a better deal. -16, x equals -5. So then you know that the answer is -5,4. And then if you weren't sure if you were right, you know, you could look in the back of the book. If it was an even number, then what are you going to do to know you're right? You're going to plug those back into the equations. Should they work for one or both? And it should be both. If they don't work for both, then you don't have the right point. You don't have the solution. Okay, so those are some pretty tough ones, so you might want to get online and try some examples, or you know, there were some other examples. There's a story problem there that you can look through. I don't want to make the video too long though, because I know you have 20-minute classes. So give it a shot, rewatch it if you need to, and have a good Christmas break.